Good day everyone, and welcome to where we are putting together solutions to those problems in math and science that we are getting problems with. In this video, we will be concentrating on CSEC Mathematics and specifically the past paper questions in the topic of statistics. We'll be looking at the past paper questions from May 2009 to 2013. Feel free to like the video and add any comments down below so we can make a video to help you in any area of math or science at the CSEC or CAPE level. Let's look at the 10 major topics in CSEC Mathematics, and our focus in this video is on the fifth topic, statistics. This is tested in the multiple choice paper 1, for 6 questions out of the possible 60, and in paper 2 for 9 marks out of the 100 marks. Let's recall what statistics is. It is a branch of mathematics dealing with large collections of data or information, and it can be presented in terms of different formats. So if we consider that, then we can subdivide this into data being either in an ungrouped or grouped, and that the statistical diagrams that may be presented with it includes pie charts, bar graphs, line graphs, usually in the ungrouped section, and histograms, frequency polygons, and cumulative frequency curves or ogives in the grouped section. Not just that, but we also must take into account that there are central tendencies that we can get from both factors, whether it's grouped or ungrouped, such as the mean, the mode, or the median, and also measures of dispersion, which include calculating the range of the data, the interquartile range, the semi-interquartile range, and even the standard deviation. In the years 2009, 2011, 2012, and 2013, all 4 years, dealt specifically with the statistical diagram of ogives or cumulative frequency curves, while 2010 dealt with histograms. So as we look at the past paper, May 2009, number 7, the question says, the table below shows the time to the nearest minute that 80 students waited to be served at a school canteen. So if we take a look at our table, we can see that the data has been organized into groups. The first class interval is 1 to 5, meaning the students who waited between 1, 2, 3, 4, or 5 minutes. How many students waited so long? 4 students. And in the second interval, from 6 minutes to 10 minutes, those who waited, 7 of them waited there, and so on and so forth. And we can see the maximum time that any student waited was between 36 to 40 minutes. If we tally or total the number of students in all, we should be getting 80. 4 plus 7 plus 11 going on. And this agrees with the question above that there are 80 students who waited. Now that we know that, we can attempt part A. Copy and complete the table showing the cumulative frequency. Since we have the first 2 columns completed and partially the third column, we now just need to complete the cumulative frequency in the third column. Let's recall to calculate the cumulative frequency, what it's telling us is the total frequency or the total number of students up to that point in time. So in the first interval, there were 4 students, so the cumulative frequency is 4. In the second, there were 7 students and 4 from the previous, so 4 plus 7 is equal to 11. And 11 is 22. And we go on, as we go to solve to the fourth interval, we had 22 students already, and adding the fourth interval with 18 more gives us 22 and 18 is equal to 40. And 22, by following the pattern, will give us 62. And 10 more will give us 72. And 5 more, 77, and 3 more, 80. So we have been able to complete the cumulative frequency. Now that we have done that, you can now look at part B. Use the values to complete the cumulative frequency curve. Now, as we look at this curve, remember, it's a graph of cumulative frequency versus waiting time in minutes. So our x-axis should be the waiting time in minutes, and we can see our waiting time ran from 0 to 40. So the minimum we should go to is 40 or 50 according to the size of our graph. By plotting those values along the x-axis, remember that in my graph, the darker lines are 2 centimeters apart. So 0, and then 2 centimeters later will be 10 if I'm going to the right. Another 2 centimeters is 20 and 30 and 40 and so on. And similarly, on the y-axis, which is our cumulative frequency, then we plot from 0 up to at least 80 or even to 100, where we go into steps of 20 for every 2 centimeters. What I've found is that many students get problems to identify the smaller lines in between. So let's look at how we can identify that. If we look at the vertically red lines or red arrows, we can plot 1, 2, 3, 4 of them between 0 and 10. What does that tell us? It tells us that on the x-axis, for each block of 10 minutes, we can break it up into 5 parts. So 5 into 10 is 2 minutes. As such, the first line is the 0 line, and then 2 minutes, 4, 6, 8, and then 10. So we're going in increments of 2. We can do this similarly on the y-axis, running 4 lines horizontally across, pointing to the right. And those red lines indicate that we're cutting that into 5 parts. So each block of 20 students will be cut into 5. And 5 into 20 is 4. As such, we have 0, 4, 8, 12, 16, 20. And that way we can easily plot points on this graph very accurately. Now, in going on to plot the cumulative frequency curve, let's recall that there are a couple things that are necessary. First of all, plotting for each group or each class interval will require the upper boundary. Now, the first interval ends at 5, that's its upper limit, and the second interval begins at 6, that's its lower limit. So, the upper boundary means that the point where that if we left it at 1 to 5, it would be like we're plotting a bar graph. But we're trying to make it look like a histogram to close up the spaces, so we shift the upper limit, right? And by shifting it, it's now called the upper boundary. So the upper boundary is halfway between 5 and 6, which is 5.5. And similarly, for the second class interval, 10 will be shifted halfway between 10 and 11, which is 10.5. There's another trick where we can just look at each of the intervals, and go vertically downwards and see how much we increase by. That's called the class width. So that is 1 plus 5 is equal to 6. 6 and 5 is 11, and we keep adding 5. So if we do that with the boundaries, we get 5.5, 10.5, 15.5, straight up to 40.5. And we've gotten all the upper boundaries. But let's recall that a cumulative frequency curve starts on the x-axis. As such, we need to get an initial point. So if we subtract 5 from the 5.5, we will get 0.5. And at 0.5, what was our cumulative frequency? 0. So now we have all the values where we can plot our graph. Let's recall that when we are plotting the graph, we're given two options. Either we use a dot with a circle in it, a circle around it, which I have indicated as a red, or as an X. I will be using, as a standard for me, an X throughout. So we plot our points, the first point being where the X value is 0.5 and the Y value is 0. The second being 5.5 as the X value and the Y value being 4, taking our upper boundaries and our cumulative frequency curves. And we continue until we plot all the points. And now, what do? We draw a smooth, thin curve passing through all the points. Not a series of straight lines, That is a mistake that many students make. Now that we've completed that, we can go on to part C. Estimate from the graph first the median for the data. Now, if we look at our cumulative frequency, we had a total of 80. So the middle of that will give us our median. So the middle of 80 is 40. So I'm drawing a red line from 40 on the y-axis on the cumulative frequency until it intersects the curve. And where it hits the curve, we now come vertically downwards. And that value will be our median. And that will be in minutes. In the second part of C, the number of students who waited was not more than 30 minutes. Or we can say less than or equal to 29 minutes. As such, where do we get 29 minutes? We get it looking on the x-axis. So I'm using a blue line, and from 29 minutes, I'm drawing a line upwards until it intersects with the curve. Remember, the whole of part C is estimating from the graph. So we're using the curve. So when it hits the curve, we now continue the line to the left until it hits the cumulative frequency axis. And that will be our value of the number of students who waited not more than 30 minutes. And in the last part of the question, the probability that a student waited for not more than 18 minutes or less than or equal to 17 minutes. As such, we do similarly what we did with the blue line. We started at 17 using the green line, and we draw our lines upwards, intersect with the curve, and then go to the left. However, in this question, what is different between part 2 and part 3 is they're asking us for the probability, meaning when we read off our value, we must put it out of our total. And what is the total number of students we had? 80 students. May 2010, number 7. A class of 24 students threw the cricket ball at sports. The distance thrown by each student was measured to the nearest meter. The results are shown below. And we can see where they give us the results from 22 meters, 50 meters, straight up to 60 meters. And from there, we're given a table with the distance in meters versus frequency. And they've given us the first two class intervals. From 20 to 29 meters, 3 students through that distance. From the next class interval, 30 to 39, 5 students through that distance. So let's look at part A. Copy and complete the frequency table for the data shown above. So if we look at this, we can see because of the class intervals, it moved from 20, and if we go vertically downwards to 30, which means that they added 10, so that's the class width. So the next class interval will be from 40 to 49, 50 to 59, 60 to 69. Because we must maintain the same class width throughout the entire table. And by looking at the values given above, we can check from 40 to 49. You can pause the video here and you check to see for each of the class intervals. Right. So for the first class interval, 40 to 49, our third class interval, when we counted, there are 8 students who through that distance, and 6 students in the next interval, and in the final interval from 60 to 69, the largest distance, 2 students through that distance. And we can double check. If we add the frequencies, 3 plus 5 plus 8 plus 6 plus 2 will give us 24. And if we look at the information given above, we have 4 rows with 6 columns. So 4 by 6 will be the same 24. So it collaborates. Now we move on to part B. State the lower boundary for the class interval 20 to 29. So that is our first class interval that was given in the table. And if we look at number 20, that is our lower limit. If we consider now a boundary, it would mean that we're expanding it somewhat so that it moves from the point of a bar chart into a histogram. So just like 29 to 30, in order for them to meet, they meet halfway, which will be in the middle, 29.5. it means it's moving by 0.5. Similarly, the lower limit will get to 0.5 less. So 20 minus 0.5 will give us 19.5. So that will be our lower boundary. Now, part C says, using a scale of 1 centimeter to be 5 meters on the x-axis, and that will be measuring distance, and 1 centimeter to be equal to 1 student on the y-axis, which will be our frequency, draw a histogram to illustrate the data. So what I've done is I've set up the graph, which is a graph of frequency versus distance in meters, and we've labeled the x-axis distance in meters, and we've moved from 0 to 10 to 20 and so forth, straight up to 70. And the reason that I've set it up like this is because in my larger blocks, which are marked a little darker, the distance there is 2 centimeters. So from the scale, 1 centimeter is equal to 5 meters distance. So 2 centimeters will be equal to 10 meters in distance. So that's why we got those markings. On the y-axis, since it is 2 centimeter squares that I have, you have to check your graph paper and see what you are practicing on, right? Then for me, 1 centimeter is equal to 1 student. So 2 centimeters, because it's 2 centimeter blocks I have, will be 2 students. So along the y-axis will be 0, 2, 4, 6, 8, up to 10. Now, let's draw it as if it is a bar chart. So using a bar chart, in the first instance will be 20 to 29. That will be the height of 3. And the second interval, 30 to 39, 5. 40 to 49, 8. 50 to 59, 6. And the last one, 60 to 69, 2. Now that we have gotten that as the bar chart, let's move it into histogram, which means to say that the spaces will now be closed. So, part D says, determine the number of students who threw the ball a distance of 50 meters or more. This doesn't require that we actually need the graph, but we can actually get it from the table as well. So the number of students who got it for 50 or more would mean the last 2 intervals. In 50 to 59, 6 students threw that distance and 2 more in the last one. So 6 and 2 would be 8 students. The probability that a student chosen at random threw the ball a distance of 50 meters or more. Probability means to say that we're taking the same 8 students and we're converting it to a fraction. 8 out of the total number of students, which was 24. In May 2011, number 7, the question states, the table below shows the distribution of the masses of 100 packages. As such, if we look at our table, where it's given mass, and you can see it's given in groups, right? So the group data, the class intervals are 1 to 10, 11 to 20, and so on, right? So they keep increasing by 10. And the number of packages are 12, 28, and as such, that if we total the number of packages, right, sigma f, that will give us 100. Because the question as above stated of 100 packages. So now we can go on to part A, which is to copy and complete the table. And if we do that, we're completing the third column, the cumulative frequency. So at the end of 2 intervals, we had 12 plus 28 equal to 40 packages. And then if we go on, we add another 30 in the third one, so it'll give us 70. And then 22 more will give us 92. And of course, the last 8 will give us 100. So it works out correctly. Now part B, using a scale of approximately 2 centimeters is equal to 10 kg on the x-axis, right? And 1 centimeter to be equal to 10 packages on the y-axis. Then when we plot our graph, we plot on our x-axis, right? Make sure and label, right, mass in kilograms on the x-axis. And if you look at it, you see the largest value is 50. So we go and we plot from 0 up to 50 or 60, as the case may be. And remember to maintain your scale. The scale that I'm using here in this graph paper, 2 centimeters is the darker colored boxes. So from 0 to 2 centimeters later would be 10. Right? So that will give us 10 kilograms. And continuing. And similarly on the y-axis, 1 centimeter is 10 packages and I have dark boxes at every 2 centimeters. So 2 centimeters will be 20 packages, and that will be my cumulative frequency running along the y-axis up to 100. And of course, let's break it up. So when we break it up, because I've found that students normally get problems here trying to identify the exact position of when we have to plot points accurately. So I've put 4 red arrows vertically upwards in order to break it up, and that means that we've broken up the x-axis and the first one from 0 to 10 into 5 parts. So each block of 10 kilograms, right, is broken up into 5 parts. So 5 into 10 is 2 kilograms. So each small one is 2 kilograms. And similarly, doing the same horizontally, horizontal red arrows going to the right on the y-axis from 0 to 20 means that the y-axis, each block of 20 packages is broken up into 5 parts. So 4 packages, which means on the flat line is 0 packages. The first line is 4, 8, 12, 16, and of course the dark line is 20 packages. So now that we're able to identify exactly where each of these are, we can now plot. Right? But remember, when we plot in a cumulative frequency curve, we need to get the upper boundary. So the upper boundary of the first interval between 10 and 11 is 10.5. And then for the second one, 20.5, and going on following the format up to 50.5. And of course, we have to invent a point beforehand where it was initial. So if we subtract 10, right, from 10.5, we'll get 0.5. At this point in time, the total frequency was 0. So now we can plot these points, right, using the x as we identified from before. We could use the one with the dot and the circle, or this. I'll be sticking with this format of x. Right, so we put the x at the first point, 0.5 is 0, and we keep plotting all the other points, 1, 2, 3, 4, 5, right, up to, 6, up to 100. Now that we've been able to plot the points accurately, you please stop your video and you plot the graph. This is very, very important to practice this question to get good at it, that you are able to plot the graph accurately. Now that we've done that, then we resume by drawing a smooth curve through all the points, starting from 0 up to 100. Right? From there now, part C asks us to estimate from the graph, meaning to work out part C, we have to use the graph to get it. So the first thing they're asking us for in part 1 is to find the median. Right? The median of 100, the middle of that is 50. So I start at 50 on the y-axis, draw a dotted line across in red, and where it intersects the curve, I now draw vertically downwards, and I can read off my mass, and that will be my median, right, in kilograms, of course. And similarly for part 2, what is the probability that a package chosen at random has a mass which is less than 35 kilograms? So where do I get 35 kilograms? That's my starting point. That's on my x-axis. So if I take my 35 and I plot upwards with my blue dotted line until it hits the curve, when it hits the curve, I now go to the left, and that will give me my cumulative frequency value. Notice that it's a probability, so that means we write it out of the total. So we're writing our value out of 100. In May 2012, number 7, question reads, the table below shows the ages to the nearest year of the persons who visited the clinic during a particular week. And if we look at the information, we can see in the first column of ages that they are put into group data format, so that the first group is 40 to 49 years. And how many persons visited the clinic? 4 persons. And similarly for all 5 class intervals, or all 5 groups, we got the information. And of course, they went into the third column of cumulative frequency, where generally when we have a cumulative frequency graph, they eventually ask us to extract information dealing with median from it. So the number of persons in total who visited in the first class interval was 4, and in the second interval before plus 11, which is 15. Right, so if we check, we can tell easily that the total number of persons is 50, right? And the question asks us to copy and complete the table to show. So if we copy and complete, we can see from the third interval, we had 15 in the second and we added 20 more. So 15 plus 20 would be 35 individuals from the ages 40 to 69. And if we include the people who are up to 79, so we add another, that other fourth group, we'd have to add 12 more to that, and that will give us 47. And of course, the last three, 47 and 3 is 50. So it clarifies that we were doing the correct question. Now the question asks us in part B, using a scale of approximately 2 centimeters is equal to 10 years, right, on the x-axis, and 1 centimeter equal to 5 persons on the y-axis, draw the curve. And for us, this scale that I'm using here, the large blocks are 2 centimeters. So when I'm plotting my x-axis, first of all, I must label it age in years, and I'm plotting starting from 30 up to 90 at least, right? So that will cover all our values. And each block, major block, according to what I have, the scale that I'm using on my graph is 2 centimeters. Make sure and measure yours to see that it is 2 centimeters as well. Don't assume. Some graph books, according to who the printer is, maybe 1 centimeter. It will vary accordingly. So mine is 2 centimeters here from 30 to 40, right? And then another 2 centimeters is 50, and you keep adding, right? So just as we've done that on the x-axis, on the y-axis will be the cumulative frequency, and the scale says 1 centimeter is 5 persons, but my blocks are 2 centimeters. So 2 centimeters will give us 10 persons. So I start from 0, I go up 0, 10, 20, up to at least 50, because that is my cumulative frequency. And of course now, we want to clarify the points on the inside, so that way we could clearly be able to plot points accurately. So we draw 4 vertical arrows there from 30 to 40, right? That means we have 5 small spaces. So if we look at our x-axis, each block is of 10 years. And that's cut into 5 parts. So each one of the small blocks is 2 years. So 30, 32, 34, 36, 38, and of course 40. So it works. And if we do similarly with the y-axis, using those horizontal red arrows, and we do the same thing, we recognize that each block of 10 persons is cut into 5 parts, so each one has 2 persons on it. Right. Now that we recognize that, right, we can now go and plot our graphs. But of course, remember that plotting a cumulative frequency curve requires which value? It requires the upper boundary. And in the first interval, we can see 49 is the upper limit of the first interval, and 50 is the lower limit of the second interval. So if we were to meet in the middle, which would be our upper boundary, it would be 49.5. And similarly, because if we look at the class width, 40, you add 10 to jump to 50, add 10 to 60, add 10 to 70. Similarly, we can add 10 to go to get the other boundaries. So 49.5 will give us 59.5, 69.5, 79.5, 89.5. And of course, we need an initial value. So the initial value is minus 10 from 49.5, and that would give us 39.5. So now that we remember at 39.5, what was our frequency? What was the number of persons there? 0. So now we have all the information ready to plot the graph. I'm using my standard x for myself. So 39.5, right, would be my y value, and 0 would be my cumulative frequency. Sorry, 39.5 is my x value, and 0 is my y value. And I continue, 49.5 at 4, 59.5 at 15, 35, 47, and of course we end with 50. Now that we've been able to plot our 6 points, right? Remember, our cumulative frequency curve must start from the x-axis. If we plotted only 5 points, we would be floating above the x-axis. Right, so we have this. Now we draw a smooth, thin curve through all the points, right? And then we can work out the last part, part C. Use your graph to estimate the median age for the data. And how do we get median? Median will be the middle of our cumulative. Our total is 50 people we are dealing with, so the middle of that is 25. So I draw a red dotted line. You use your pencil only, and draw a dotted line starting from 25, right, across. And where it intercepts with the smooth curve, we come vertically downwards, and of course we read off the value in years, and that would be our median age for the data given. And similarly now for part 2, what is the probability that a person who visited the clinic was 75 years or younger? So where would our initial information is 75 years? We will get that on the x-axis. So we go to 75 and we plot. I'm using a blue line, dotted line going up. Where it hits the curve, right? We now go across, and there we will read off, and that will be our value. However, it's a probability. So it means we're taking our value and we're putting it out of the total, which is out of 50. In our final question in this first video, in May 2013, number 7, the question states, the table below shows the amount to the nearest dollar spent by how many? 40 students, and that's an important piece of information, at the school canteen during a period of 1 week. So if you look at the table, we can see they're put into group data, and the format is they're put into 1 to 10. That's how much money there is. So how many students spent up to $10? 3 students. And then how many students spent up to $20? Between 11 and 20, 7 students, and so on and so forth, up to a maximum of $60. So now that we've given this information, we can double check our total frequency or total number of students, and that should give us 40. And that coincides with the 40 students given above in the question. Now part A says to copy and complete the table to show cumulative frequency. And of course, when we're doing that, we know to get the cumulative frequency, it's the total amount of intervals that students will. In the first one, it will be 3, because there are 3 alone in the first group. When we go up to 20, we'll be including the first group and the second group. 3 plus 7 is 10. We'll include 9 in the third group. 10 and 9 is 19. And we continue. And if we continue 19 and 11, that will give us our first value, 30 to add. And 30 and 8 is 38. And 38 and 2 is 40. And it totals just as it said. So it coincides again. Let's go on to part B, which is to use a scale of approximately 1 cm equal to $5 on the x-axis. Right, so that's our graph that we're looking at, graph of cumulative frequency versus amount spent in dollars. And when we plot our graph, let's recall that on the x-axis, amount spent in dollars, and if we follow that scale, 1 cm is equal to $5, then 2 cm, because those are the size of my blocks, will be $10. So I plot 0, 10, 20, up to 60. And on the y-axis, 1 cm is 5 students. And if I'm following the y-axis there, my blocks are 2 centimeters. If your blocks are 1 centimeter, then you could plot in 5, 10, 15. Mine are 2 centimeters, so I'll plot easily on my cumulative frequency. 2 cm will give me 0, 10, 20, going up the road until 50. Right? A little more than our 40 that we needed. Right? Now that we know that, let's just dissect these small blocks here so we can see it. That if we dissect using the red vertical lines on the x-axis, we can see that there are 4 lines here because there are 4 small blocks, 4 small lines, so it'll give us 5 blocks. So each block of $10 is broken up into 5 parts, so each small block is worth $2. So if we count it 0, 2, 4, 6, 8, 10, and we do something similarly using horizontal red lines for the y-axis, we can see that each block of 10 students divided by 5 is 2 students. So on the cumulative frequency for these students, it'll be 0, 2, 4, 6, 8, 10 as well. And as such now, we just need to get the upper boundaries. So if you look at the first interval, it ends at 10 and the second interval begins at 11. So the upper boundary is where they meet halfway. Halfway between 10 and 11 is 10.5. So we have 10.5, and we can see that if we move from one interval to another, we are adding 10 coming downwards. 1 and 10 is 11, 11 and 10 is 21, 21 and 10, 31, or 10 and 10, 20, 20 and 10, 30, and so on. So that's the class width. As such, we can do the same with the upper boundary, 10.5. If we add 10 to that, 20.5, 30.5, and we continue until we get 60.5. And of course, we need an initial value, right? So the initial value for the cumulative graph to be on the x-axis, 10.5 take away 10 is 0.5. And at 0.5, what is our frequency? Our frequency is 0. So now we have the amount spent, we have all the x values, we have the cumulative frequency for all 7 points. So that we have the y values, we can now plot. Right? And as we started plotting, as usual, first point being at 0, 3, 10, just calling out the x values here, 19, 30, 38, and of course 40. Right? So we can now use our graph, right? after, of course, we've drawn our smooth curve. So let's pause the video here and draw a smooth, clean, thin pointed curve. When we finish, use our graph to estimate the median amount of money spent. So if there's 40 in all, then we're drawing a line from the cumulative frequency halfway, which is half of 40 is 20. So we draw a red dotted line going across, right, from left to right until it intersects with the smooth curve. And when it intersects, we now draw it downwards, and that will give us the amount of money spent as being our median amount. And now that we've done that, we can now do part 2. The probability that a student chosen at random spent less than $23 during the week. So where do we get the information $23? We look at it, we can find it on the x-axis. So on the x-axis, we plot a blue line. You, of course, using only your pencil, no colors. And when we plot it vertically upwards, where it intersects with the graph, we go across to the left with another horizontal line, and that gives us our value. But remember, you're not putting your value just as is. It's a probability, so you have to put it out of the total, which is out of 40. In our next video, we will be continuing with these CSEC Math solutions for the topic of statistics, where we will be doing the next 5 years, May 2014 to 2018.